So we're in section 5.1.
No, say that again? Yeah, for sure. For sure. For sure.
And we're going to talk about using trig identities.
For sure.
Now, we did a little bit of this in chapter 4 where we simplified things with our trig identities. We're going to do more with that. We're going into a little more. We're going to go into a little more depth with trig identities, with trig functions in general. So now we have an idea of what the trig functions are. We defined sine, cosine, and tangent. We defined all of our cofunctions. We know how to evaluate our trig functions. What we're doing in this chapter is we're going to work on simplifying expressions that have trig functions in them. We're going to develop new identities, and we're going to solve equations that have to do with trig functions. So we have an idea of how they work, how they fit together. Now we're going to work on how we actually use them a little more in application. Trig equations come up in applications, and we need to know how to work with trig functions, how to solve equations with trig functions, how to simplify expressions with trig functions, just like we've done with algebra expressions before, like our worksheet where we had to simplify the fractions and find a common denominator, all that kind of thing. The things that we know how to do with functions of x or functions of y, whatever, we're going to work on doing those same kinds of things when we have a trig function involved. So our tools, the tools that we're going to be using, one of the big tools is, and this is for all of chapter 5, our tools, this sheet of identities that I gave you. So what we're going to be working with today is just a list of identities on the first side. These are all identities that we've talked about before. We talked about them in chapter 4. We're going to start using them with a little more, just a little more regularity, and with using them a little more in depth. So our tools that we're going to be using in this chapter are our identities, and those are going to be important. The other tools that we can use when we're working with trig functions, trig expressions, we're going to be factoring. We're going to be simplifying. So simplifying is like the example we did from our worksheet, where we rewrite something that's a little more complicated in a form that is maybe less complicated, or maybe more like what we want to work with. We're going to add and subtract, and often it involves fractions. So we're going to be dealing with common denominators. And our common denominators have to do with trig functions, so that throws a little twist into what we're doing. And we're also going to be using substitution. And our identities help us with substitution. So what I want to do today is just do several examples of using these identities on this first side of the page, just to simplify or rewrite expressions or equations that have to do with trig functions. So the kinds of work that you'll have to do in the homework. The reason that we're doing this is because often when we're working with trig functions, if we have some kind of application where trig functions are involved, we end up with some kind of expression, some kind of equation that's complicated, that we want to rewrite, we want to simplify, so it's easier to work with. So what we're doing today is just practicing with the simplifying part, so that when we get to the part where we're actually solving equations or using our functions and applications, we have some ability to simplify and to rewrite to make our equations easier to work with. So I'm just going to do several examples today. So the first one, we know that we have the cosecant of u is minus 5/3, and the cosine of u is greater than 0. We want to find the other trig functions. Now, we've done problems like this before. Does anybody, if just looking at this, anybody have an idea of how using the methods that we've used before, how would we go about starting on this problem? Draw a triangle. So what we've done before is use the cosecants, figure out what sides of the triangle that tell us about, and draw a triangle. Well, what I want to do today is show us just a different way to go about this using identities. So the cosecant is the reciprocal of what? Sine. So I'm going to say that the sine of u, I'm just taking the reciprocal, is minus 3/5. And we have a Pythagorean identity over there on the upper right hand side of your page, where it says that sine squared u plus cosine squared u equals 1. So I'm going to use this identity, and I'm going to plug this in here for sine u. So I'm going to write that minus 3/5 squared plus cosine squared u equals 1. So subtract minus 3/5 squared, I get that the cosine squared of u equals 1 minus negative 3/5 squared. I just subtracted 3/5 squared from both sides. And so cosine squared u equals 1 minus, if I square this out, I get 9/25. Find a common denominator here. This is 25/25 minus 9/25. So cosine squared u equals 16/25. Take the square root of both sides, and the cosine of u equals 4/5. So just a slightly different way to go about this. Now if I have the sine and the cosine, I have the cosecant. From the cosine, I can get the secant. Just take the reciprocal. From the sine and the cosine, I can also get the tangent. The tangent of my angle is just the sine of the angle divided by the cosine of the angle. And then the cotangent is the reciprocal of that. So by using this identity, I've found the cosine, and then I can use what we know about the other trig functions to find the rest of the trig functions. Questions on that? So just a slightly different way of solving that problem rather than drawing the triangle. End up with the same result, just using identities rather than drawing the triangle. All right, let's look at another example. And I'm just going to try to get through as many of these examples as I can, just so we can see as many as possible. So this one, we have the cosecant squared cosecant squared x times the cotangent of x minus the cotangent of x. And we're simplifying these. Anybody have an idea of what we can do with this? What's common to both terms? The cotangent of x. So let's factor. So I'm going to factor out a cotangent of x. So I'm going to write this as cotangent of x times cosecant squared x minus 1. And over in the top right, I have an identity that tells me that 1 plus cotangent squared u equals cosecant squared u. If I subtract 1 from both sides here, I get that the cotangent squared of u is cosecant squared u minus 1. So I'm just using that identity, rearranging it a little bit. So cosecant squared x minus 1 is the same as cotangent squared x. So I'm going to substitute this in. So this is cotangent x times cotangent squared x. And finally I get that this simplifies to cotangent cubed x. So this expression here simplifies to cotangent cubed x. And this is, I factored and I use this identity. So part of what we're doing is using algebra tools that we already have and also working on becoming more familiar with these identities and how we rearrange them. Questions on how I did that one? Now at first it's not 100% clear on how you do these things, but anytime you have something squared and a plus or minus 1, you should think about your Pythagorean identities. So if you have a trig function squared and you're adding 1, you're subtracting 1, look and see if it involves one of your Pythagorean identities. All right, let's look at another one. We're going to simplify tangent squared x, or not tangent squared, tangent x times the sine of x plus the cosine of x. So this one, because I can't factor anything. There's nothing to factor. There aren't any common terms. I'm going to write everything in terms of sines and cosines. And we talked about doing that before in chapter 4. So I'm going to write tangent of x as sine x over cosine x times sine x, and then we have this plus cosine x here. Now I'm going to multiply here, so I get sine squared x over cosine x plus cosine x. Now what do I need to do to add these two terms together? We need a common denominator. So I'm going to multiply this. My denominator is going to be cosine x. So I'm going to multiply this by cosine x over cosine x. And I get sine squared x plus cosine squared x, and my common denominator is cosine x. And sine squared x plus cosine squared x is what? 1. That's from our Pythagorean identities up there on the upper right. So this equals 1 over cosine x, which is the same as secant x. So this expression simplifies to secant x. Secant x is much easier to work with than this thing. So this one I converted everything to sines and cosines, and then we had to find a common denominator to add. Questions on that one? All right, let's look at another example. I'm just going to work a bunch of these so you can start to see the process here. All right, so we have the secant of t over the tangent of t minus tangent t over 1 plus secant t. And we want to simplify this. So how am I going to, what do I need to do with these two? There's nothing I can factor. I have these fractions. So what do I need to do with these fractions? How do I subtract these fractions? We have to get a common denominator to subtract these fractions. So what's our common denominator? How do I find a common denominator for these two fractions? Multiply the right one by tangent of t, so I'm going to multiply this by tangent of t over tangent of t. Right, so when we multiply the left one by this one, I'm just going to move my minus sign over here. And I'm going to multiply this by 1 plus secant t over 1 plus secant t. So that will give me my common denominator of 1 plus secant t times tangent t. So now I'm going to multiply these out and add everything together. So for this one, I get the secant of t plus secant squared t. I just distributed here. Minus, I still have this minus sign here. Tangent squared t here, all over my common denominator of tangent t times 1 plus secant t. Now I have a secant squared t and a tangent t, and they're subtracting, so I have an identity over there on the upper right, my Pythagorean identity. Anytime we have these trig functions squared, that should make you think of your Pythagorean identities. I have an identity that says that the tangent squared u plus 1 equals secant squared u. So if I subtract tangent squared from both sides, I get 1 equals secant squared u minus tangent squared. So that's from my identity. So I'm going to substitute 1 in here for secant squared t minus tangent t. So this is secant t plus 1 over tangent t times, and I'm going to turn this around, secant t plus 1. And I'm going to put this in parentheses. What happens to the secant t plus 1? They cancel. And this finally just equals 1 over tangent t, which is what? cotangent. So this complicated expression simplifies to just cotangent t. So we're just, on this one, we had to add these two fractions, and then whenever you see a trig function squared, you should think, can I use a Pythagorean identity? Trig function squared is a hint that you might be able to use a Pythagorean identity. So we found a common denominator, added them, used a Pythagorean identity, and then canceled the like terms in the numerator and denominator. Questions on that one? So part of what we're doing, if this seems a little confusing at first, it is a little challenging to figure out how do I go about it, what do I need to do. Part of what we're doing is trying to build up a little familiarity. As you get a little better at it, it will make more sense. It's kind of like the graphing. As you practice more, it starts making more sense. But part of it is just learning to recognize the patterns. And if we haven't done that yet, it can be a little tricky. But as you do more, you'll start seeing the patterns, and it'll start coming more easily. All right, I just want to do a couple more examples. All right, so this one, we want to factor. We want to factor cosine squared x minus 1. Now, my hint earlier was when we see a trig function squared, we think of Pythagorean identity. Well, let's take a look and see if that's going to help us out. So we know that sine squared x plus cosine squared x equals 1. Well, if we rearrange this, if I subtract 1 from both sides, I get sine squared x plus cosine squared x minus 1 equals 0. And then subtract sine squared, so I get cosine squared x minus 1 equals negative sine squared x. That really doesn't get us anywhere here. I can rewrite this as negative sine squared, but that doesn't help us out. And the problem tells us to factor. So what if I had written to factor, I'm just going to write a related problem. What if I had said factor x squared minus 1? And we want to factor that. What is it, Melissa? This is x plus 1 times x minus 1. We need two numbers that multiply to negative 1 and add to 0. Well, this is the exact same problem, but instead of x, we just have a cosine of x. So I can write this as cosine squared x minus 1 equals cosine x plus 1 times the cosine x minus 1. So if we wanted to factor this, I'm just thinking of, rather than thinking of my function or my variable as x, think of it as the cosine of x. And it's the exact same problem. What if we wanted to factor sine squared u minus 3 sine u minus 10? How could we factor that? So we're thinking of, rather than x being my variable, we're thinking of sine of u being the variable. So I need my parentheses, sine of u and sine of u. I need two numbers that multiply to 10 and multiply to negative 10 and add to negative 3. Negative 5 and 2. So we have a negative 5. And did we get our signs right? Negative 5 and plus 2. And that's how we can factor this expression. So we factor it just as if the sine squared, rather than the sine squared, we just had an x. And this is going to be these particular types of simplifications are going to be really important when we start solving trigonometric equations. All right, one last example. I want to rewrite one over secant of x minus 1 so it's not a fraction. So this one is probably the most tricky one that we have to work with. Whenever I have a trig function like this in the denominator, and I want to simplify this, it's kind of like when you work with complex numbers, it's kind of like multiplying by the conjugate. So it's a similar idea. So when we see something like this where we have a fraction, we're going to multiply. I'm going to take 1 over secant x minus 1, and I'm going to multiply the numerator and denominator by secant x plus 1. So this fraction just equals 1, but it turns out that this is going to let me simplify this denominator. So this equals secant x plus 1 over, and to multiply these, if it helps you out to write parentheses so you remember to FOIL this, I get, when I FOIL this out, I get secant squared x minus 1. My first is secant squared, the outside is plus secant x, the inside is minus secant x, and the last I get the minus 1. And now I have secant squared x minus 1. That should make us think Pythagorean identity. Secant squared minus x, or secant squared x minus 1 is what? Secant squared x minus 1 is tangent squared. That's the second Pythagorean identity there. So this equals secant x plus 1 over tangent squared x. Whoops, I forgot something here. Well, we still have a fraction here. Well, now I can separate this into two fractions. So tangent squared x is my common denominator. So this equals secant x over tangent squared x plus 1 over tangent squared x. Tangent squared x is my common denominator here. And now I just write everything in terms of sines and cosines. This is 1 over cosine x over sine squared x over cosine squared x plus 1 over tangent squared x is cotangent squared x. And I'm going to divide this fraction by multiplying by the reciprocal. So that's 1 over cosine x times cosine squared x over sine squared x plus cotangent squared x. One of my cosines cancels here, so I get that this is cosine x times 1 over sine squared x plus cotangent squared x, and I'm finally almost finished, equals cosine x times 1 over sine squared x is cosecant squared x plus cotangent squared x. So I've rewritten that so it's not a fraction. All right, so we did a bunch of examples. The way I think about these problems is they're like puzzles. If there's often a lot more than one way to get to your solution. If you're not sure what to do, just try something. If it doesn't work, then go back and try something else. These are like I think of these as like doing puzzles. So sometimes you start and it doesn't lead anywhere, but then that might give you a hint as to where you might want to go. So just a couple of general hints. When you see a trig function squared and you're working with these, that should give you a hint that maybe you're working with the Pythagorean identities, and rewriting things in terms of sines and cosines can often help with these as well. All right, homework. There you go.